Space is often depicted as a serene void, a silent stage for the celestial ballet of stars and planets. Yet this tranquil facade belies a hidden reality, the turbulent and often dangerous realm of space weather. Our sun, the anchor of our solar system, is not always the benevolent life-giver we perceive. It is a raging inferno, spewing forth a constant stream of charged particles and powerful electromagnetic radiation. This is space weather, and understanding it is crucial to our ventures beyond Earth's protective atmosphere. Space weather encompasses a variety of phenomena, all stemming from the sun's immense energy. These phenomena can have a profound impact on our spacecraft and even our planet. Imagine a massive solar flare, a sudden burst of energy equivalent to billions of atomic bombs erupting from the sun's surface. Or envision a coronal mass ejection, a billion-ton cloud of plasma hurtling through space at millions of miles per hour. These are not scenes from a science fiction film. They are very real events that can disrupt our technology and endanger human life. As we venture further into space, sending probes to distant planets and potentially humans to Mars and beyond, our understanding and ability to navigate space weather becomes paramount. Just as sailors of old relied on their knowledge of wind and waves, so too must spacefarers learn to navigate the unpredictable storms of the cosmos. Our journey into the cosmos is inextricably linked to the sun's temperament. The future of space exploration hinges on our ability to not only withstand, but also harness the forces of space weather. It is a challenge that demands our ingenuity, our scientific prowess, and a healthy dose of respect for the sheer power of our nearest star. Only then can we truly become a spacefaring civilization. Our sun is a dynamic star, a churning ball of plasma in constant flux. Its activity gives rise to space weather phenomena, each with potential for disruption. Solar flares are sudden, intense bursts of energy from the sun's surface. This energy travels at the speed of light, reaching Earth in minutes. Solar flares can disrupt radio communications and damage satellites. Coronal mass ejections, or CMEs, involve the sun spewing out clouds of plasma and magnetic fields. CMEs can trigger geomagnetic storms, disrupting power grids and electronics. The solar wind is a constant stream of charged particles from the sun. It's like a breeze carrying the sun's magnetic field through the solar system. The solar wind can erode spacecraft materials and affect electronics. Understanding solar flares, CMEs, and the solar wind is essential for protecting our technological assets. While space weather phenomena originate from the sun, their effects are not limited to the vacuum of space. Earth, with its technological dependence, is surprisingly vulnerable to the sun's outbursts. Understanding these vulnerabilities is crucial for safeguarding our infrastructure and way of life. One of the most significant impacts of space weather is on our power grids. Imagine a powerful geomagnetic storm triggered by a CME hitting Earth. This storm can induce electric currents in long conductors, such as power lines, leading to voltage fluctuations and even blackouts. The 1989 Quebec blackout, which left millions without power, serves as a stark reminder of this vulnerability. Satellite communication, the backbone of our interconnected world, is also susceptible to space weather. Solar flares, with their intense bursts of radiation, can disrupt the ionosphere, a layer of Earth's atmosphere crucial for radio wave propagation. This disruption can lead to communication outages, GPS errors, and interruptions in navigation systems, impacting aviation, shipping, and countless other industries that rely on these technologies. Beyond these immediate technological impacts, space weather can also pose risks to astronauts. Outside the protective shield of Earth's magnetic field, astronauts are exposed to higher levels of radiation from solar flares and CMEs. This radiation can damage DNA, increase the risk of cancer, and cause acute radiation sickness. As we venture further into space, ensuring the safety of our astronauts from the hazards of space weather becomes paramount. Understanding and mitigating the impacts of space weather on Earth is not merely a scientific endeavor, it is a societal imperative. Just as we prepare for hurricanes and earthquakes, so too must we develop strategies to protect our technology, infrastructure, and people from the unpredictable fury of the sun. Our interconnected world, increasingly reliant on space-based technologies, demands vigilance and preparedness in the face of space weather hazards.